Well, welcome. I'm Mark Ahlstrom, and as president of the Energy Systems Integration Group Board of Directors, it's my honor to welcome you to the 2025 Spring Technical Workshop. So how are you feeling? There's plenty of challenge and uncertainty in our industry and our world, but there's also opportunity and responsibility. Society runs on reliable and sustainable energy, and now it needs a lot more of it, driven by electrification across industries and customers, and of course, amplified by data centers. The pace of electric demand growth over the next 20 years is expected to be a six-fold increase compared to the last 20, resulting in more than a 50% increase in the annual power demand. To meet this pace of growing demand, we need a lot of generation, transmission, load participation, collaboration, creativity, engineering, and execution. We'll need a diverse set of new resources and flexibility, and we'll need it all. It's no exaggeration to say, even just looking at the US power system, that we here will be responsible for deploying more than $1 trillion of capital investments in the future. At NextEra Energy alone, our capital investment plan exceeds $120 billion over the next 4 years. Gas-fired generation and nuclear will be part of the customer solutions, but most of that's in 2030 and beyond and at a cost. The fastest and cheapest approach will be storage for capacity and renewables for energy, and we expect to double our renewables and storage fleet. So everything we'll be talking about here this week is very, very important for all of us here and for society as a whole. So thanks for being here. What a great turnout. How many of you are here for your first ESIG technical workshop? Wow, at least half, right? Yeah, that's wonderful. Let me give you a background about why I think ESIG is so very unique and important to us here. Some of us have been coming to these things for 20 years now, in my case, I think, and I wouldn't miss them. ESIG is a global member-based nonprofit organization for those of us supporting the technical aspects of grid transformation and energy systems integration. We do this through workshops like this, through tutorials, webinars, blogs, working groups, and task forces for our members, and by producing technical resource materials and briefing materials for decision makers. ESIG convenes key participants, like we're doing here this week, to chart the technical pathways in a manner that is collaborative, reliable, economic, trusted, and sustainable. As you'll see this week, by bringing talented and dedicated people like you together at the right time to talk about the right things, ESIG functions as a catalyst to make progress faster and better. You also notice speakers and attendees from many organizations and areas of expertise from around North America and around the world, because that's what it takes to transform complex energy systems. Grid operators, utilities, equipment manufacturers, power plant developers, researchers, planners, consultants, modelers, software and AI companies, NGOs, and industry associations are all here as a safe and productive place to share, learn, and collaborate on solutions. We're particularly honored and pleased to say that Mr. Zhen Huang is joining us this week, the Deputy Chief Engineer of the State Grid Corporation of China and the President of Northeast Branch of State Grid. Mr. Huang has worked in system operations and dispatch during his career and will be giving a presentation on Tuesday afternoon on the integration of high levels of clean energy in China's Northeast power grid. A number of colleagues from China also made the trip to participate in this workshop, which we greatly appreciate. And we'll hear more from Debbie later, but we have international visitors from around the world who are joining us here, and thank you for coming and being part of this great week. For the workshop this week, I want to really thank our workshop sponsors, Analytics, WEG, Electric Power Engineers, Reactive Technologies, Hatch, and GE Vernova, and recognize NextEra Energy, Meta, and Polaris Systems Optimization as sustaining members of ESIG this year. If your organization is a member, I deeply thank you, and please remember to attend a very brief annual meeting tomorrow at 12:15 right here for our annual report and election of board members. If you're not yet a member of ESIG, I hope you will join. The modest annual membership fee is based on the annual budget of your organization and provides membership benefits to your entire staff. Independent consultants and individuals can also join, and ESIG provides free memberships to students of accredited educational organizations. Membership allows you to participate in ESIG working groups and task forces, including the new large loads task force that you'll be hearing about this week, as well as reduced member registration rates and other member benefits. This week, let's all make a special effort as well to engage students and young professionals who are here. They are vital to our future. If you're a student or a young professional, I invite you to also join us tomorrow evening at 5:30 before the workshop reception begins at 6:30, so that you can meet with me, with ESIG staff, and others who want to meet you and talk with you. And for all of you, my hope is that you find this ESIG workshop to be a safe place where you can open your minds, think creatively, ask questions without fear, and speculate wildly with friends that you know and new friends that you meet. It's important, it's fun, and it's why we're here. So now for our keynote speaker. Venkat Tirupati is Vice President of DevOps and Grid Transformation at ERCOT, the Electric Reliability Council of Texas, which many of you know very well as the innovative system operator here in Texas. In his role, Venkat oversees ERCOT's technology innovation capabilities to manage the rapidly transforming electric power grid. He joined ERCOT in 2020 as the Director of Grid and Market Solutions, previously worked at the Lower Colorado River Authority, North American Electric Reliability Corp., and Siemens Power Transmission and Distribution in various roles. He has electrical engineering degrees from the University of Mumbai and the Illinois Institute of Technology with a focus on power systems, and a Master's of Business Administration with a focus on data analytics and sustainability from the Massachusetts Institute of Technology. He's a senior member of IEEE and a registered professional engineer in the state of Texas. Please join me in welcoming Venkat to kick off our ESIG workshop.
Good afternoon, folks. Can you all hear me okay? All right, good. Thanks, Mark, for the wonderful introduction. Really appreciate that. And I don't know where Julia is sitting. Thank you, Julia, for the invitation to come and speak at the workshop here. I was not expecting crowd like this, okay, when I agreed to this. So this is really good. And I also see a lot of ERCOT faces here. So that's even more comforting for me, that if somebody asked me a question, I could actually, lean on some of the members here. So thank you for that. Mark, you said that there are several folks who are not just from this area, but from different places across the world. So welcome to Austin, welcome to Texas. And this is actually a great week to be in Austin, Texas, because this is spring break week for a lot of kids and college kids here. So I'm sure there are a lot of activities that are happening in this area, in the downtown area. And also last week there was South by Southwest. So if you had come a few days early, probably you might have caught some South by Southwest activities here. So hopefully you did that. What else? The way I've structured the presentation is I will talk a little bit about what's happening in Texas in general, share about opportunities that exist in different areas, right? Opportunities to innovate. And I think as Mark laid out, that's what we need. And end with a little bit about how do we structure organizations and things like that to innovate together. I have about 50 minutes, I think. So what I'm planning to do is 25 minutes of presentation and then 25 minutes of Q&A. Hopefully that works. And so we'll wait for the questions until the end and we go from there. Right. So again, the talk is opportunities and challenges in the Texas power grid from our perspective. One thing that Julia reminded me when I accepted this invitation was Venkat, ERCOT uses a lot of acronyms. So let's just make sure that there aren't too many acronyms in the presentation. And I realized when I was going through the slides that I start off with an acronym and we never really say what ERCOT stands for, right? So I think Mark mentioned that. Electric Reliability Council of Texas, Electric Reliability Council of Texas, not Corporation of Texas, because I've seen even ERCOT employees get confused by that, right? So again, I'm here to present a perspective from our side in terms of what's happening, what are the opportunities, and what are the challenges, right? All right. So there's East, there's West, and there's us, okay? And yeah, we have 4 DC ties that are connected to the north and the south, but otherwise we are on our own. ERCOT serves about 90% of the Texas electric load, 75% of the Texas land. We have more than 54,000 miles of transmission, more than 1,250 generating units. And again, there was an acronym in our standard slides called PUNS. PUNS stands for Private Use Networks. I made sure that that acronym doesn't stay. And so, yeah, I mean, we do have about 1,200 megawatts of DC ties with the East and the West. So anyway, that's about Texas and ERCOT in general. We have 4 things that are in our mission. Keep the grid reliable, keep the markets efficient, provide open access to transmission, and provide retail choice to customers in Texas, right? Really, 4 things that are our mission. And you can see here when the whole market was deregulated back in 1999, this was the structure. If you look at, I guess your left, you'll see that generation in Texas is competitive. On the right-hand side, retailers, competitive. And in the middle, you have T&D, which is regulated by the PUC. And so that's sort of the structure, you have to keep in mind when I'm talking through some of the things here. So generation deregulated, retail deregulated, and then transmission and distribution, which is regulated. Some numbers, every utility or every ISO, when we come and talk, we have to show these numbers. So you cannot escape this slide, okay? So let me just walk through some numbers there. And if I can point, I guess. Okay, there we go. So this is our peak demand record, 85,000 megawatts that was set back in the summer of 2023. And then this is our installed capacity that we published in our CDR report. Again, CDR capacity, demand and reserves report that we publish. We have about 115 gigawatts of expected capacity for the upcoming summer. And we did about 3.8 billion transmission projects. We endorsed them in the region. So that's a significant number. If you look here in terms of our generating capacity right now, natural gas accounts for about 44%. We have wind at 25%, coal at 9%, solar at 13%, right? And of course, this is the installed capacity. When you look at the energy usage, the numbers shift a little bit. But what has been the story in Texas so far is what's here. We have about 39 gigawatts of installed wind capacity in the region. And we hit a record of 28 gigawatts just a couple of weeks ago in terms of the record of wind generation. And that represents a penetration of about 69% for the wind. That's the wind penetration record that we set of 69%. If you look at our solar has been the story in Texas for the last few years. And we are at 30 gigawatts right now in terms of our installed capacity. We hit a record of 25 gigawatts on March 10th of this year. And on March 1st, we hit a penetration record of 54%, where half of our load was pretty much getting served by solar. And for the combined record, we have combined wind and solar. Again, this is a preliminary number. On March 1st of this year, we hit about 76%, where 76%, which is about 36 gigawatts, and that's the latest record on that. Right? And again, if you look at our battery storage, we have about 10 gigawatts of installed capacity of batteries in the region as of Jan of this year. And we have seen a discharge record of close to 5 gigawatts just a week ago, March 10th. Right? So this sort of represents where we are in terms of, the growth of the renewables, where we are with the total demand. And above all, we serve about 27 million customers in the region, okay? All right. This is a picture that ERCOT folks love to use. How many people in this room have actually seen this picture? Not many. So maybe let me explain that. So the electric grid then and now. I don't know whoever made this slide what then means. I'm going to say that then is like 2 decades ago maybe, or even before that. So it used to be pretty clear, right? You have dispatchable generation, nuclear, diesel, coal, et cetera, and then you have transmission, distribution, and then you have load, and then that's about it, right? It used to be pretty boring, the way the electric grid, was run. But now, just visually, just looking at that picture, you see so many blocks now, right? The world has just changed. In addition to the dispatchable generation, now we have variable generation with wind and solar and everything. And on the on this side, you have electric load, you have demand response, and look at this arrow. It used to be unidirectional. Now it is bidirectional, where there are reverse power flows that happen from the distribution grid onto the transmission grid. We have our favorite data centers that are out there, and energy storage is right here. Energy storage could be a gen, could be a load, when it's charging and discharging. So it's just that things have become much more complex now. And as a grid operator, we suppose, our mission is to keep the lights on. It just becomes more complex. I showed this slide to one of our development program engineers, and one of the engineers there had a question. So Venkat, why are you putting DG here? Shouldn't DG be on this side? Right? Because if you are representing this as the gen and this as a load, why is it here? But I think one of the things that we're also trying to show in this slide is that this is a supply, and there's like a geographic representation of how the power flows, right? And then the DG is sitting in the distribution. And then we have all these electric vehicles right now. In Texas, it hasn't risen to the level that we worry about it too much from a grid operator perspective, but we are aware that there's a lot of electric vehicles and there's load, and this load is mobile, meaning that where the charge doesn't remain constant, right? So anyway, bottom line is the world used to be pretty simple, but the world is a lot more complex now, and as an operator, it keeps us on our toes, right? All right. So the next few slides, I'm just going to talk about like what's happening in Texas, right? And so I'll start off with the load. And right now, Texas population as of 2023 was 30 million. And just in 2024 alone, we had more than 500,000 new residents who moved to Texas, more than 500,000. Okay. And if you look at the projections on this graph, you have the year on the x-axis, you have the population in millions on the y-axis, and you can see the trajectory, right? The estimated growth is by 2028, we'll have about 33 million folks residing in Texas. And it's just people moving, right? And with them, the businesses, new businesses prop up, existing businesses grow, there's just more load. And during the peak load, half of our load tends to be residential. So you can see how much of an impact this could have on our load. Looking at this other graph, again on the x-axis you have the years, and we have these load numbers. Sitting at 2024, our peak was 85. And if you look at 2030, our peak is projected to be at 150 gigawatts. Okay. It took us about, 15, 20 years to move from 50 number to 85. And we are going to go from 85 to about 150 in less than 5 years. So this is phenomenal load growth. Right? And what is the composition of that, right? If you look here, this is crypto, this is data center, hydrogen industrial, and oil and gas. Okay, and this is what we have in our this is what we use in our studies. And there was a House Bill 5066 that got passed, and which is when all the TSP started giving us all the projected load information. And when you plug in those numbers, this is what you get. I keep hearing that this number keeps changing all the time. So I don't know what's the latest number there. But when we made this slide, it was about 150 gigawatts, right? Just out of curiosity, how many people in this room truly believe that we will hit 150 gigawatts by 2030? There's only one, maybe a couple of people, right? But if you ask me, I don't know the exact number. We do know that there's a lot of growth. Texas, we have policies to support the economic growth, right? And if I take these numbers at face value, that's what I get. But if you discount it by 40%, 50%, but even then the numbers are really high. It's not like this 150 will suddenly become only 90, right? These numbers are high. And so we just have a lot of challenges ahead of us to meet this demand. So my key takeaway with this slide is there's just going to be growth in Texas. Okay? So what's happening on the supply side? This is, again, on the x-axis, you have your fuel type. And on the y-axis, you have the megawatt numbers. And from January of 2021 to March of 2025, okay, which is about, 4 years? 4 years and some months, we synchronized about 45 gigawatts of new generation within Texas, okay, in the ERCOT region. And of that, solar is about 24 gigawatts. Batteries are about 10 gigawatt. We have wind is about, say, 8 gigawatt, and natural gas about 4 gigawatts. So you can see where the supply is going in our region. I also put some information on the dispatchable thermal generation here. From 2009 all the way to 24, right, which is about 25 years. In ERCOT, we have only seen about 1,700 megawatts of new dispatchable thermal generation. Okay, it's because as things were getting added, we also lost or retired. A lot of generation retired. I think that's a key number to remember. We didn't have much of dispatchable thermal generation in the state, but we added quite a bit of 61 gigawatts of new solar, wind, were added in the region. So that's sort of what's on our interconnection queue right now. Again, this number, 400 gigawatts. We have 400 gigawatts of capacity that is sitting in our interconnection queue right now. And this number used to be 300 something, and as of February, now it's at 400. And what's in the queue? Again, solar and batteries dominate with more than 81% of that. And you can see the numbers there, right? I mean, if I could orient you on this slide, what you have is the fuel technology on this side. You have the gigawatt numbers on the y-axis. And if I take battery as an example, you can see every year what is in the queue, right? And so that's all battery. So combined solar and battery, again, accounts for more than 300 gigawatts in our interconnection queue. Again, these are significant numbers, right? So I talked about the load, I talked about the supply, now let's talk about T&D, right? Demand can come in really fast. What we are seeing now is load really wants to interconnect, and they can interconnect really fast now. So they could interconnect within 6 to 12 months. If you look at generation, even with our connect and manage process, ERCOT probably is the best in the nation when it comes to generator interconnection process. We still take about 6 to 24 months. And then transmission lags even more, right? To build transmission, sometimes it takes 3 to 6 years. So you have load that is growing fast, and it's coming really quickly. You have generation that lags, and then you have T&D that lags even more. So the point is, with the forecasted pace of load growth, it could exceed the pace at which the transmission capacity can be built. And that's a significant challenge for us in the region, right? That's just not it. We have DG, generation that is out in the distribution grid, and that number has been steadily increasing in our region. So back in 2015, the amount of DG was only 650 megawatts. But if you look at the growth, you can see where we are right now. In 2023, we were at about 5 gigawatts. I'm not sure what the latest number on that is, but that's been the growth of DG in Texas, right? And if you notice, I don't know if you can read that or not, but that's just the solar, rooftop solar, and you can see the sort of the growth of that within the region. So I want to explain this a little bit. So you have seen what's happening in Texas from a load perspective, from a supply perspective, from T&D. So there are a bunch of other things that are changing the dynamics of what happens in the Texas power grid, right? We talked about the load. We talked about what we are seeing in the batteries, what we are seeing in distributed energy resources, and of course, artificial intelligence. I cannot escape any conversation these days, any day, without talking about AI. So AI has to be in my slide. So there's AI, there's cyber threats, there's new kind of generation technology, there's grid edge technologies, cloud, and everything. So the dynamics of what's happening on the grid is just very diverse now. There's just so much that's happening, right? While at the same time, as an ISO, as I said, my mission is to keep the grid reliable, keep the markets efficient, my primary mission. So we have to balance the gen and load. We have to provide voltage support. We have to do frequency support. I have to ensure that there are enough resources. I have to ensure the efficiency. I have to ensure competitive retail prices. I have to ensure that there is a good congestion management and provide open access. So I have a changing grid here, which is growing so fast, and I still have to meet all my basic necessities to run the grid. How do we reconcile all of that, right? The way at least I think about it is, let's tie these things together through innovation and transformation, right? For me, if we cannot innovate and transform ourselves, there is no way in the world we can meet the things that are happening in our grid, right? So that's how I tie it together. For the next few slides, what I tried to do was showcase some of the opportunities that exist in each of the different sectors. In my mind, I thought, should I talk about innovations and opportunities that exist in operations, planning, etc., or should I just stick with innovations in the load and the generation area, right? I just stuck with the later. So you will see in the next few slides about opportunities that exist in each of the different sectors, right? At least in my mind, that's how I think about it. All right, so this is on the load side. And these are not prioritized in any way. I just, just 1 to 6, okay? And the first one that I think of is modeling, right? Especially with the large loads, be it data centers, be it, hydrogen electrolyzers, be it oil and gas, traditional. We just need to find a better way to model these large loads. Otherwise, we will not understand how they behave, and we will run into all sorts of operational challenges, right? And it was gratifying to see that ESIG in the agenda, that there is actually a panel on large loads, and there's quite a bit of discussion that is happening on the large loads. And I hope that modeling is a key element of that, right? And then, of course, forecasting. We all have to do a better job with forecasting, right? Especially with the latest, technologies that we have at our hand. I think we should be able to do a better job of how much of all of this is going to happen, right? And look at the macroeconomic factors and look at what's happening at a individual county level and things like that, and be able to really predict the demand growth better. And also about interconnecting, right? I think ERCOT has been working with the market participants to come up with a good large load interconnection process. I think it's in the works right now. And it's not just about interconnecting, it's about interconnecting fast, it's about interconnecting reliably. We want to make sure that load just doesn't show up and cause problems on the grid, right? And so we are working on this process, and I think there are plenty of opportunities to work on in terms of interconnecting large loads. The fourth one is about situational awareness. We can't operate the grid well if I don't have my eyes and ears on what's happening on the grid, right? And so from that perspective, especially given the relationship that we have with the loads, in the future, I think there'll be a lot of emphasis on making sure that we have some visibility on what's happening with the load so that we can, we are situationally more aware. The other thing that I'm particularly passionate about is the flexibility. We cannot treat all the load as some homogeneous entity, right? These loads are very heterogeneous. And I think there's a lot of flexibility that is available for us that we need to leverage from an operational perspective, from a markets perspective, right? When you talk to the data center folks, they say that, hey, I'm not going to be at whatever level that you heard of all the time, right? If it depends on if I'm training, if folks are using me for inference or whatever, right? So I think there's a lot of flexibility that we need to tap into and provide the right incentives for these folks so that they can actually think about the flexibility, right? And that is at a large load level. And in fact, I don't know how many of you are aware, but ERCOT has this whole concept of controllable load resource, CLRs. And the CLRs are load resources that follow our dispatch instructions. And we have about, last I checked, about 1200 megawatts of CLRs in the system. And that's a mechanism that we really want to encourage everybody to participate so that we have much better dispatchability for those loads. And the last one is tooling. And tooling is something that I sort of consistently talk about. When you look at all the tools that we have in our hands to run some of these studies and things like that, I think there's always scope for improving these tools, right? Especially when it comes to loads and modeling and how to run studies and things like that. So anyway, 6 things that I wanted to highlight on the load side. On the supply side, something very similar. We have all these inverter-based resources. We have to do a better job of modeling them, especially dynamic models, so that we can simulate the behavior well. And I think same thing, right? ESIG has task forces that are looking into that, which is very relevant. Essential reliability services. With the changing supply mix, the resource mix, it's essential that they provide the essential reliability services that we have gotten used to from the synchronous generation, right? So, I mean, I do see a lot of action with the whole grid forming inverters and things like that. I think, again, there's a panel on grid forming inverters. If not tomorrow, maybe the day after tomorrow, I think, right? Again, that is very important. Same thing with interconnecting. Yes, we are fast, but we are not fast enough. If the load is going that fast, we need to be able to do things much more faster on the generator interconnection process. So I think there's a lot of scope for improvements on that. And again, interconnect fast, but interconnect reliably, right? Same thing for the resource side. We need to have a much better awareness in terms of what's happening on the grid, things like that, on the supply side. Resource adequacy has become a topic lately with all the load growth. Yeah, you see a lot of generation, in our interconnection queue. But is that generation going to be available during certain critical hours, when you need it, right? And if you look at some of the capacity factor numbers for the variable generation or the new methodology that we have, ELCC methodology, there are times where you cannot depend on the variable, generation resources. You need to have dispatchable generation around. So resource adequacy is something that, we are, there are a lot of opportunities. ERCOT has recently transitioned away from seasonal forecasting of resource adequacy to more of a monthly, look ahead, which is very good. And same thing, right? Forecasting. Forecasting generally as a topic on the supply side is again very important. And tooling. We at ERCOT, when we discuss, some of these challenges, it really boils down to, hey, do we have the right kind of tools to do some of these studies? And we always realize that there are a lot of opportunities that, that could be leveraged in that space. So that's sort of my quick 7 points on the supply side. T&D. Step 765, step up. Again, that's an acronym. Okay, that's an acronym. Strategic Transmission Expansion Plan. Okay, with all the load growth and all the supply changes on our side, we felt that we need to innovate in terms of the voltage level that we have in the system to carry the kind of power that is needed to meet the load. Who knows the answer to this? I'm sure a lot of people know this. But what is the highest voltage level that we have in Texas? 345, right? So this is a step up for us. And we have put a plan together for this. And I think it's going through the approval processes right now. But again, that sort of innovation that is needed on the transmission side to meet the supply and the demand. DER flexibility. Again, you saw the growth of distributed generation in Texas. At some point, it'll start actually creating some problems for us on the transmission side. And we would like to really tap into the flexibility that exists within the DERs. And there is a pilot project that we have going right now called ADER, Aggregated Distribution Energy Resource Pilot. It's been going on for a couple of years now, where we said, hey, you could aggregate DER devices, and participate in the market, ancillary services and energy. And that has been successful. And I think that particular project is going to move away from sort of a pilot phase into a regular ERCOT mechanisms. Happy about that. And again, when it comes to T&D, with all the events that we are seeing on the climate side that are climate related, we want to ensure that There's a lot of innovation that happens on the T&D side, right? Be it planning for resiliency, making sure the infrastructure can hold, and things like that. Situational awareness, I mean, this theme is going to run, in all my slides, which is we need to be able to know what's happening on the grid. We need to have the eyes and ears on what's happening on the grid as the grid is changing so rapidly. Congestion management, optimizing the flow to make sure that there aren't, enough overloads on the system. And again, tooling. T&D, this space is so ripe for innovation in terms of all the tools that we need to do, that we need to have to run the grid well. I'm watching the time as well, okay? All right. On the market side, real-time co-optimization, this was long overdue. This has been done in all the other ISOs. And hopefully we'll get this implemented this year, by end of this year. And this is us optimizing the energy and ancillary services in real time every 5 minutes, rather than what we do right now, which we don't co-optimize right now. Again, we have to think about ancillary services in general, think about how to optimize the procurement of ancillary services. Do we need new kinds of ancillary services, etc., right? I think this area again is ripe for innovation. On the energy storage resources, you saw how much is in our interconnection queue. And so we need to be able to better manage the energy storage resources on our system. And that provides a lot of opportunities for us and for the market as well. Flexibility products, I think flexibility is something that, again, we are very passionate about. We think that there are market products that we could come up with that will encourage flexibility. In fact, demand response is something that ERCOT is actively working on right now. And I think PUC is also very interested in demand response. So hopefully you'll see something in the demand response area from ERCOT. Again, that's an opportunity for innovation. Reliability services. I think National Grid in UK does it. They have a market for reactive power, I think. And it's about time that we also start thinking about different kinds of reliability products from a market perspective. And of course, tooling, right? All the different tools that we have, be it economic dispatch, unit commitments, etc., they are all ripe for innovation in terms of speed, efficiency, etc., right? So I think there's just a lot of scope for innovation in markets as well. And the last one that I have in terms of innovation that is needed and opportunities are in the emerging technologies. And I saw in the agenda that there are quite a few presentations that are in this space. Of course, AI, ERCOT is looking at AI in terms of all the different techniques and how we can leverage AI to improve our operations. Grid enhancing technologies, be it dynamic ratings, be it topology optimization, be it better power flow techniques, etc. I think they're all, again, there's a lot of need for that. Grid edge technologies and clubbing that with smart grid management. There's a lot of stuff that happens on the grid edge. The meters are so smart. I'm sure you must have heard about AMI 3.0 and all of that, right? There's a lot of decisions that could be made at the edge of the grid without even coming up the chain, right? I think there's a lot of opportunities for innovation there. And generation technologies, right? The nuclear is back in fashion these days, right? We hear about small modular reactors, we hear about fusion, and it's geothermal, tidal, offshore wind, everything, right? When you have that kind of load growth that you're projecting, I feel like everything should be considered and everything needs to be innovated on because we need all of those. And again, there's just a lot of tooling that needs to, that provides a lot of opportunities. With that, what are we focused on from an ERCOT perspective? At ERCOT, we have a team of folks who are working on research, innovation, transformation sort of activities. And we are focused on these 10 things. And these are in a prioritized order. Okay? I'm just going to quickly rattle through them. We are focused on how to manage these energy storage resources, how to develop demand response products, how to manage the grid with rapid penetration of DERs, how to keep the power system secure from a dynamics perspective, from a steady state perspective, and how to leverage some of the AI ML capabilities that are out there, how to assess the power system strength, inertia, things like that, right? So at least these are our top 10 things that we are working on. When I say we are working on, some are white papers that we will produce, and share publicly at some point in the next few months. Some are proof of concepts that we are working on with some vendors in the space, and we will make sure that all of that becomes public in the near future on our website. All right. So I talked about, yes, innovation that could be done in the supply, in the load side, in the T&D side, etc. But I think innovation cannot be done just by ERCOT, cannot be done by individual utilities themselves. I think there needs to be some sort of a framework where we put it all together. And this is sort of my way of looking at it. Whatever we do needs to be collaborative, and ESIG is a great example of that, right? Where there's a lot of collaboration that is happening between ISOs and utilities and all the different folks in the ecosystem. And we need to be agile. It's not that you can wait for 4 or 5 years for innovation to happen. Things need to happen very fast. It needs to be operationally focused, right? I mean, in the sense that whatever we do, ultimately our job is to keep the lights on. So it needs to be operationally focused. This is something that people don't give too much attention to. It's fun to talk about innovation. It's fun to talk about technology. But ultimately, you need culture within the organizations to get the innovation to happen. And it needs to be a closed loop process. And what we have at ERCOT is this process that you see here, where we define the vision, we define the goals, we identify the problems, very clear problem definitions, we prototype and test, we implement and scale it, and then we communicate and collaborate, right? I think that's the closed loop process that I'm talking about. And ultimately, you need to create knowledge so that you are sharing whatever you're learning, right? So this is the framework that we are operating under at ERCOT, and hopefully it's a framework that's helpful for the industry in general. With that, I think I'm hitting my time okay. Quick recap. The Texas power grid is rapidly evolving. There are plenty of opportunities on the supply side, on the demand side, on the grid side. Innovation and transformation are vital to deal with these challenges. I think we all need to collaborate and do joint innovation. We are open for partnerships from an ERCOT perspective. I have to plug in my innovation summit that is happening on May 6th. Again, we are going to talk about all the innovation that we are doing, innovation that other ISOs are doing, and how we can collaborate together. And I firmly believe in the last one, which is it's really an all of the above comprehensive approach that we need as an industry to meet this rapidly changing grid. It can't just be this technology versus this technology. Okay. Well, I have to end this with some sort of a note, I guess. There has never been a more exciting time to shape the power industry, right? This is a phenomenal time to be in the industry. In fact, out of my undergraduate class of 60 folks, only 3 of us are left in the power industry. Everybody just went and took different branches. But now I actually get phone calls from my friends who are no longer in the electrical industry in terms of all the excitement that they see happening, right? So it is just fun, I think, to be in this industry in general right now. And my 3 key takeaways are: embrace the challenges together, right? Let's seize these opportunities, and let's be that force as a group to drive that transformation that is absolutely needed for this industry right now. With that, thank you, and have a fantastic, spring technical workshop. Thank you.
For the last part of this opening session, being designated as an IEEE Fellow is a special recognition for extraordinary accomplishments in the IEEE technical fields. The IEEE Power and Energy Society recently announced that ESIG Executive Director Debra has been elected to the IEEE Fellows Class of 2025. So please join me in bringing Debra up for the industry overview and congratulating her on her well-deserved recognition as an IEEE Fellow.
Thank you, guys. It's very kind of you. So I wanted to welcome everyone to our spring workshop, and thank you, Venkat. That was a great presentation. It was a really nice overview of what you're dealing with at ERCOT and the innovations and opportunities that we have to look forward to. For those of you, since a lot of you are new, I wanted to make sure you knew about the ESIG disclaimer. So a couple upfront disclaimers. One thing to note is that anything you hear this week, it's the view of the speaker, not of ESIG. I wouldn't go investing millions of dollars based solely on something you heard here. We welcome a broad range of participants, including regulators, policymakers. We ask that you excuse yourself if discussions enter topics that could be of ex parte concern. And we ask that all of you obey antitrust laws and not try to restrain competition in general, but especially here at ESIG meetings. And then finally, we don't tolerate discrimination or harassment, and This is an educational event. There are no dumb questions. We ask that everyone be appropriate and respectful in their interactions. Okay, so now let's talk about energy. So I would be remiss if I didn't acknowledge that probably everyone in this room is suffering some whiplash trauma right now. It's everything from like how fast we've been running to power new data centers, and then DeepSeek announces, oh, maybe you only need an order of magnitude less of computational power, to new executive orders, stopping offshore wind, stopping permits, federal permits and approvals for onshore wind, new executive orders freezing funding for programs under the Inflation Reduction Act and the IIJA, Infrastructure Investment Jobs Act. And now there's a lot of uncertainty looming on tax credits. So a huge amount of uncertainty out there. And then to things like, oh, now there's going to be a tariff on electricity between the US and Canada, and oh no, now there's not. Uncertainty had already been like off the charts, and now it's like we had to rescale the y-axis because it's even more off the charts than it was before. One thing that continues to be the case, and this is perhaps linked to the comments that Bob Cummings just made, grid operators are up at night worrying about the basic resource adequacy issues for several years. We're retiring thermal plants. We've got clogged interconnection queues. Transmission timelines are slow. Venkat was showing that. And that's been going on now for several years. And more recently, we've been finding that once projects get through the interconnection queue, you've got supply chain issues. High cost of capital has conspired with supply chain issues to make it very difficult to build resources. And then most recently in this past year, we've seen this very large boom in data center growth and other large load growth, and a very, very fast, high magnitude load growth that makes these challenges even harder. And I'd say nowhere is this seen better than in the PJM capacity prices. So the last capacity auction, you saw auction prices that were almost an order of magnitude than they were the previous year. And so, ratepayers are going to be paying these costs. And some folks are thinking there's going to be a new dash to gas. But as the CEO of NextEra said last week, it takes at least 5 years to build a new gas plant. And they cost over 3 times what they cost a few years ago. So if you didn't already order your turbine and get your permits, building renewables and storage is going to be cheaper and faster. And all this is leading to renewed interest in virtual power plants, demand response, and what we can do on the customer side of the ledger. So there are things that we're turning to help deal with this. With that as the backdrop, average electricity prices are increasing, right? So you've got consumers, regulators, policymakers, they're concerned about increasing energy bills, and that reduces their appetite for new infrastructure like transmission and distribution. So folks are asking, why should we build more transmission when the transmission portion of electricity bills has already grown significantly in some regions? And it's really incumbent upon us to ensure that we're doing everything as efficiently, we're squeezing everything out of our infrastructure as we can, and ensuring that this infrastructure is planned as efficiently as possible if we want to justify growth. The overall theme of this week's workshop is really around large loads. That's sort of the big story these days. And we're seeing, and Venkat mentioned this, AI may be leading to a nuclear renaissance. There's a ton of interest now in small modular reactors, even micro reactors, right? The 1 megawatt reactors, based on nuclear submarine technology. This is just a long list showing things like partnering between the hyperscalers and the nuclear industry. You've got, for example, Ahlstrom, a nuclear company that's being chaired by OpenAI's CEO, Sam Altman. There's lots of innovation happening here too. For example, Constellation is looking at adding SMRs to existing nuclear plant sites. And then last week, we heard there was a pledge from some of the hyperscalers to triple nuclear capacity by 2050. So some of us were talking about this last night, and we were talking about how, after the Vogtle plant and the Santee Cooper's plant down in Georgia and South Carolina, a lot of us used to be really pessimistic, thinking that just on the basis of financial reasons alone, that it would be difficult to finance nuclear again because of the very severe overruns we had in budget and in timelines on those plants. And that said, I heard recently that there was a United Arab Emirates nuclear plant, 5.5 gigawatts, that was recently commissioned using US Nuclear Regulatory Commission codes and standards. And Department of Energy says the capital cost in that plant is $5,500 a kilowatt, with the last unit of that being much cheaper. And so I think there is room for optimism. It's certainly something, we need to really keep our eye on. This space is innovating very fast. Large loads have created a lot of concern, however, because industry is reporting various grid events caused by the behavior of large loads. It's everything from this top graphic, which is showing ride-through events where 400 megawatts of data center may trip offline because of a transmission fault, to on the left, this is showing 1,500 megawatt data center coming offline because of a transmission fault and not coming back immediately, to the bottom right showing 40 megawatt oscillations in ERCOT. So this really highlights the need to define and ensure grid-friendly behavior from large loads so that these grid events don't lead to more severe significant problems as we're ramping up large loads. And we're going to be discussing a lot of this, especially on Thursday this week. Some folks are thinking, oh, large loads, this is a problem I need to deal with as an engineer. I think we need to really think of large loads as an opportunity, large loads as grid assets. If you think about it, all data centers have storage and backup generation. Hyperscalers are likely going to build 10 gigawatts of on-site generation in the next 2 years. And the key for us in industry is to think about, how do we turn these into grid assets? Like, what kinds of services would you want from a data center? You want fast frequency response. Someone's doing that right now in Scandinavia. Do you want peak shaving? Someone else is doing that using their behind the meter batteries. Do you want the load to disconnect when there's a stress event, right? So loads did disconnect during stress events. Data centers did disconnect during Winter Storm Uri, and in the Nordic system, all those system operators now are developing standard terms for interruptible agreements. So that's what we need, more of these standardized terms and ways of having services from these large loads. Do you want to use the large loads backup generation during a stress event? In Wyoming, Microsoft has got backup gas turbines that can help serve Black Hills Energy when there's a stress event. And some of these large loads, like Eric was alluding to in his question, are inherently fast and flexible, and they want exposure to spot prices, and they can be dispatched, right? They just need to find RTOs and utilities that's going to allow them to do this, right? Besides ERCOT. ERCOT allows them to do this, but we need to make it so that more places beyond Texas are able to do this as well. So for those of you who don't know, we at ESIG have kicked off a large loads task force. If you are interested in joining this, so you have to be a member, so you can talk to Ryan outside at the desk about membership. We are running meetings on different work streams, everything from interconnection to load forecasting. And we are running webinars, a webinar series, and the schedule for some of the different work streams is up here, but we are anticipating the work to be finalized and completed starting the end of this year and then going into the beginning of next year. And then for those of you who don't know about the broader work that we do at ESIG, we have 5 working groups: cross-system planning, operations and markets, DERs, reliability, and then research and education. And under those working groups are different projects and task forces. And this is just a list of what's going on right now. But if you see something that we're missing, you need to let us know. If you think that there's some problem in industry that needs a group like this to come together to try to solve that, to do some analysis, some modeling, some best practices, you need to let us know. And Thursday is the ideal time to do that. So for those of you who may not know, we published a few reports at the beginning of this year, one looking at the benefits of making batteries grid forming, not grid following. One on market design, wholesale electricity market design, looking at visions for electricity markets for the future. And then one on demand response, looking at why demand response participation is limited and how to unlock its potential. And we are in the process of finalizing a long list of reports by June. So our publications department's super busy right now. Everything from grid stability to grid enhancing technologies to electric vehicles and integrated planning. So an introduction to what we're going to talk about this week. So this morning, we had a great workshop on the I2X interconnection standards that Julia led. Thank you very much, Venkat, for that great presentation again. After the break, we're going to have a opening plenary session on large loads, challenges and solutions. That'll be a discussion session. And then tomorrow, after breakfast, we have sessions looking at grid forming inverters, including looking at grid forming inverters for large loads, demand flexibility, including looking at things like value of lost load in Texas. We have sessions on control room of the future and system operations. We'll be looking at DERs, not just providing services on the bulk system, but also on the distribution system. Tomorrow, around noon, we're going to have our annual membership meeting. So if you're a member, please come to the meeting. We're going to be voting on the board of directors. And then after lunch, we'll have a session on FERC 901. So FERC asking NERC to have standards for inverter-based resources. Session on integrated planning. And then we're going to have some networking activities. And this is new. I hope you guys really enjoy this. We heard from a lot of folks that they'd like to do something more active and be able to network with each other. So you get to go hiking around Ladybird Lake. You get to go kayaking or take a tour of the library and get a rooftop view of the city. If you haven't signed up, go see Ryan and Lacey outside. And then we have the student and young professionals reception. If you're interested, if you're a student, you're a young professional, please come. And if you're interested in advising, mentoring, or hiring a student or young professional, please come. Both that reception and our main reception and the awards are moved to a new place. So what's in the program, we outgrew the original room and it's now too big. So it's going to be on the second floor here where we had lunch. So the receptions are going to be second floor of this building. And then Wednesday, we've got oscillations and stability. We're going to talk more about large loads, co-location, and other ways to faster interconnect large loads. We'll talk about grid enhancing technologies with a focus on case studies and actual folks using GETs. We'll talk about improved modeling for system planners, the focus on capacity expansion modeling. transmission planning and what's going on in transmission around the country now, and then resource adequacy issues. And then we'll do a closing plenary on scale, speed, and supply chains, and how supply chains are doing these days, and what people see as the future to help unlock that. And then on Thursday, Thursdays for members only, we have the Large Loads Workshop, a one-day workshop on interconnection process, interconnection performance specifications, and modeling needs. And then in parallel with that, we have the working group sessions. So those working groups are all going to meet, with the exception of the reliability working group. They're meeting next week. But the DER, system operations, research and education, system planning will all meet on Thursday. And that's your opportunity to basically tell us what you think ESIG should work on next and to pitch your ideas. Finally, I want to welcome especially our international participants. We have over 340 people registered this week. So this workshop has been growing and growing, especially very quickly over the last year. This includes folks from over 13 countries. Can the international participants stand up? If you came from a different country, can you just stand up and we'll just see? Okay, that's amazing. So we really appreciate that you took the time to travel here and to share your experience and knowledge. And I will also say these 13 countries do not count the great nation of Texas. So who's here from Texas? All right, I've heard that there's an awful lot of folks from Texas here. We're really excited, and everyone hopefully took note of who raised their hands, because you need to pin those people down to find out where the barbecue is. Texas is famous for their barbecue, and they'll know the best places to find it. So with that, welcome everyone. We're going to have a 30-minute break, and then we'll come in here for the opening plenary session on large loads. So thanks.